So, okay, hello, let's go to the third one. We have some results here in grams per second. Okay, now let's write to modeling. What is this model and what it shows, what for we're doing it? I already explained it and it's very long story to explain again. So, but for building a model, you should to know the emission source information, the height of this emission source, the radius inside. You need to know the gas speed, emission gas speed, and you need to know also the emission level in grams per second. Okay, so this we already have this information after our some short calculations. So it's will be not 1.5. Just to remind you, you have all number. It can be 0000 looks like something like that. So let's go. I don't know, but it will be many zeros there here. So let's go next. First of all, I recommend you to download the software. It's here. How to do it and how to work with this software, please look this video tutorial, this link, first one. And after that you will receive some graph. And please explain this graph. Second part of this exercise is preparing a dispersion map. But we cannot make map because our land department server doesn't give us ability to use the maps. So this is this exercise of mapping I'm canceling. So this second video is also cancelled. You don't need to do it, but simply for understanding, for clearing, for more information, you can simply look it. It helps you to understand what we can do with data. So okay, but anyway, we're going to build a model. So please download this software, buy this tutorial, start this software. If you're going to start it, please click to the right button and start. Here is written start as administrator. It's only one way how it works. Please start as administrator. Okay, this is software, and there in video tutorial will be written what to open here, tutorial or something like that. I don't remember exactly what I recommend you, but I'm not going to show you very long what I'm doing because it's in the video. But anyway, very short. You choose the source type, you choose the dispersion coefficient, in our case is urban, you choose the receptor high, it can be 0. You choose emission rate, it's that after our calculation. I will simply check to put many 0, like something like that. Stack high, I recommend you use 20 meters because stack high is here, 20 meter. Okay, so and this system accept only circle or round emission source, but it don't accept rectangular. We have rectangular, so if we're going to change this rectangular into the round tube, the diameter inside diameter of that would be 20 inside radius of this would be 21.8 centimeters. So multiply it to the 2, you will got a radius. You will got a diameter, sorry, you will got a diameter inside radius 21.8, multiply 2, you will got the diameter. Okay, because in reality it's rectangular, but if it would be circle or round, the diameter would be 43.6. So the model accept only round, so stack inside diameter is 43.6. Okay, so velocity, gas speed is your average. I don't know what you got, so maybe 0.9. Temperature in Kelvin, inside gas temperature was 25 degrees of Celsius. Please find a way how to recalculate it into the Kelvin. Okay, I will write 300, but it's wrong. So let's go next one. Here you can choose the meteorological classes. It's already explained on previous videos, so I will do it very fast. Okay, minimum distance, maximum distance, run. But please check the video on the tutorial, it's a bit longer. This is a graph of concentration of micrograms per cubic meter. You see how it's changed? This is already not very interesting, but no, it's also interesting. I don't know what graph you will get. I have this one. It depends on your own graphs. So please describe it. The sedimentation of pollution from emission source, a maximum of the distance off, and the minimum, first minimum of the distance off from source. Then it's going to increase. Please describe this graph, okay? And if you need some number, you can choose this graph like a numbers. And please add this graph also to your report. I want to see it. Output, or this way. Here you see the distance, 100 meter, concentration, distance, concentration, distance, concentration. Okay, this is micrograms per cubic meters. So you can compare it with the limit values. Of course, it's much less. You can also look at this graph and see that maximum is first maximum on the distance of some meters. So find another maximum, for example this maximum 1 kilometer, and maybe you can try to find the nearest position in Google and compare it with this place with the maximum. I don't know, if it's possible, maybe you can simply find nearest household from university, no, for example this building. Okay, so try to define the distance. This is like a rural measurement scale, or another way, check how many meters is it, and simply describe what the concentration of sedimentation from this our ventilation system would be near the nearest building by this graph. If you got it, if you have some graph which can easy to read. So but anyway, I need this graph and short description of this, because I want to know that you are understanding what's written here, what's shown here. So next part. It's part number 2. Let's see it into the another next one video.